On number one, they're both in standard form. So basically what I did was I plugged in a 0 for y, and I found x to be 2. Then I did the same thing for x. I plugged in a 0 for x and found that y was equal to 2. So those were my two intercepts. All right, then I graphed those. I put it right here and at x equals 2. Then, noticing that it was 2 over 2, that's how I found my slope. And I ended up putting the other points there. Now, it's an equal sign, so I'm going to go ahead and graph this as best I can. And we'll just do that in red. All right, it's hard to make a straight line on this. The other one, I did the same thing. I plugged in a 0 for y and found that x was equal to 4. So 1, 2, 3, 4. And then the other one, I plugged in a 0 for x and found that y was negative y equaled 4. So I knew that y had equaled negative 4. So 1, 2, 3, 4. And basically, let me go ahead and 1, 2, 3, 4 right there. I'm going to connect those two. And I bet you, if you notice, my intersection is going to be about at 3, 1. And so you need to put 3, 1 over here as my intersecting point. Okay? Number two, y equals 3 is already done for you. So 1, 2, 3. I'm going to draw a line straight across here. So there's y is equal to 3. Now, with this particular one, I could solve for y, or I can do the intercepts again. If I plug in a 0 for y, 3 times something is 15, and I know that's going to be 5. The opposite of that, let me erase that real quick. If I plug in a 0 for x, I know negative 5 times something is 15. Well, I know that y has to be negative 3. So those are the 2 points I'm going to plot. So at x equals 5, 1, 2, 3, 4, 5. And y equals negative 3. And I'm going to connect them as best I can. Now, 1, 2, 3, 1. So I'm going to go up 3 to the right 5. I'm going to do the same thing. 1, 2, 3, 1, 2, 3, 4, 5. So there's another point right there. So I'm going to connect it. And notice my connecting point is at 10, 3. All right? And that's how you would use solving by graphing. Okay, on number 3, what I want you to notice is that this is solved by substitution. This is already solved for y. So we're going to take this 5x minus 27 and we're going to plug it in for y right here. You distribute and you get 17. Now, the reason they got 17x is 2x and then 3 times 5 is 15x. So they went ahead and skipped a step and wrote 17x. And then 3 times 27 is 81. Equals to 4. Now notice they're not keeping it aligned, but they are keeping it nice and neat. They moved the 81 to the other side and added it to the 4. So basically they moved it right here. They moved that 81 right there. So 81 plus 4 is 85, and that's what they got right there. They then divided everything by 17 and got x equals 5. In doing that, they plugged it back into the y right here. And 5 times 5 is 25 minus 27 is negative 2. And so your solution is 5, negative 2. All right? Now, on number 4, if you look at number 4, they're both in standard form. But this particular one, I could solve for x. I don't have to solve for y every time. So just by moving the 2x over, that made it a 2x plus y. I'm then going to take this and plug it in over here. So that's what I did. At 2y plus 1 plus the 4y, combine like terms, you get 6y plus 1. They ended up taking the 1 to the other side because 19 minus 1 is 18. They divided it by 6, and you got y equals 3. Then, plugging it back into the x minus, so x and then minus 2 times 3, so they plugged in the 3 here, so they get x minus 6 equals 1. Well, when they add the 6 to the other side, they get 7, so your solution is 7, 3. Now, with the elimination, if you look at these, I can't eliminate the x's or the y's immediately. But what I can do is I can multiply one of them in order to eliminate one of the things. So I'm going to eliminate the x's. So what I'm going to do is I'm going to multiply this whole thing by 3. So I'm going to distribute the 3, and in doing so, that gives me 3x and 3x. Now, they could have done it by a negative, but they didn't do that in this case. So if you notice, when they multiplied that out, what they ended up getting is 3x minus 9y equals negative 39. Now, they put a parenthesis around the whole thing because they're going to subtract here. So 3x minus 3x cancels out. Negative 9 minus 7 is negative 16y. And negative 39 minus, there's a minus over here, 25 makes the 25 negative, and that equals negative 64. You divide by negative 16, and you get positive 4. And in doing so, they went back to this original equation up here. They plugged in a 4, so you end up getting x minus 12 equals negative 13. Well, when you add the 12 to both sides, you got x equals negative 1. So your solution is negative 1, 4. Now, on this particular problem, the x's and the y's don't cancel out, so we're going to have to do a little bit more. We're going to multiply the top row by 5 and the bottom row by 2. Now, in this case, notice again, they're going to make you subtract down here. You could easily multiply this top row by negative 5 and change this to an addition, but that's totally up to you. That's your prerogative. So in this case, 5 times 2 is 10, 5 times 8 is 40, and 5 times 6 is 30. Now, put a parentheses around the whole thing. We're going to subtract. So 10 minus 10 is 0. 40 minus 40 is also 0. And 30 minus 30 equals 0. Well, I got this side equal to this side. So that's going to be infinite solutions. And there's the infinity sign. On number 7, we're going to eliminate the y. So we're going to multiply this entire row by 3. And again, I wish they, whoever did the answer key, I wish they would have multiplied by negative 3. At any rate, 3 times 7 is 21, 3 times negative y is negative 3y, and 3 times 19 is 57. Since these are the same, we're forced to subtract. So 21 minus 2 is 19. Negative 3 minus a negative 3 makes that a plus plus, and those cancel out. And then finally, the last thing is 57 minus 19, which is 38. When you divide by 19, you get x equals 2. And what they did was they went ahead and plugged it into this equation here. They plugged in the 2 here. And if you notice, 2 times 2 is 4. So they end up getting 4 minus 3y equals 19. They subtracted 4 on either side. So they subtracted 4 on either side, and 19 minus 4 is 15. Then they divided by negative 3 and got y is equal to negative 5. Therefore, your solution is 2, negative 5. On number 8, over here, they multiplied the top row by 2. Now, notice this row right here. It's not in standard form, but that's okay. We're going to move it over like they did here, and you get 5x minus 2y. Now, multiply the top row by 2, you get 8x minus 2y equals negative 8. That's this right here. Now, I'm going to subtract because these two are the same. And when you do that, 8 minus 5 is 3. The two y's cancel out. And negative 8 minus 1 is negative 9. Divide by 3, and you get x equals negative 3. Then we take that answer, plug it back into one of the equations. It doesn't matter which one. So you end up getting negative 12 minus y is equal to negative 4. And then when you add the 12 to both sides, negative 4 plus 12 is a positive 8. Divide by negative 1 here, and you get y is equal to negative 8. So negative 3, negative 8 is your solution. Now, let's take a look at this one, number 9. A tennis coach took his team out for lunch and bought 8 hamburgers and 5 fries. So we're going to let x equal hamburgers, y equal fries. So you have to define your variable. So 8 hamburgers, 5 fries, and that came to a total of $24. 6 hamburgers plus 2 fries came to a total of $6.16. Now, in doing so, when you're able to set up two equations, you're able to find out how much a hamburger is and how much a fry is. And you have to determine whether you want to use systems, solve it by substitution, elimination, or graphing. Now, in this case, we're going to do elimination, and notice they're going to eliminate the x's by multiplying this by 3 and this by 4. You multiply the entire row. Notice how the entire rows change. Because the x's are the same, 24 minus 24 is cancels out. 15, now remember it's a minus here, so 15 minus 8 should be a is 23y, okay? Or actually 7y, sorry, it's 7y, and then $72 minus $66.40 is $5.60. You then divide by 7 here, and you get y is equal to 0.8 or 80 cents. So that's how much a fry is. But now we got to find out how much is a hamburger. Now, they took this first equation, they plugged in 80 cents for a fry. 5 times 80 cents turns out to be $4. So when you have 8x plus 4 equals 24, when you subtract the 4, you end up getting 8x equals 20. And so when you divide by 8, that's where you get the 2.5 or 250. So what it would have been better is each hamburger costs $2.50, each fry is 80 cents. I'm not going to go over all of these, but look at number 10, hockey tickets. So you have adult tickets and you buy child tickets. So X plus Y adds up to 24 total tickets. All right, that's this right here. And then if it's $5.50 for an adult ticket and $2 for a child ticket, all right, you're spending $83. So there's your total dollars. So remember, money, 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 and total on the top. And then, of course, you can see that they used substitution. They solved for x here and then plugged it into the other equation. On number 11, now we're talking about nickels and quarters. You know a nickel is 5 cents, a quarter is 25 cents, and the total amount of money is $8.85. Well, that's what they did. Remember, it's 5 cents per nickel. So we're going to let x equals nickels, y equal quarters. So 5 cents for a nickel, 25 cents for a quarter, adds up to the total amount of $8.85. Nickels and quarters add up to 49 coins. So now, by solving for x, you can now use substitution, and that's what they did. And if you were able to look on Canvas last night, you were able to see the solution. On number 12 and number 13, this is the inequalities. Now, notice they solved for y in this case. They subtracted 2x to both sides, then they divided both sides by -3 here. So they divided everything by -3. And when you do that, it flips the sign. So you end up getting y is greater than 2/3 x minus 2. Well, you start down here at -2, and it's a positive slope, so they went up 2, right 3, up 2, right 3, up 2, right 3, down 2, left 3, down 2, left 3. And notice those points are all on the same line. Now, look at the shading. In this case, I want to look at this part right here. Y is greater than the -2. Remember, all the y's that are greater than -2 are above, so therefore your shading is up here. Same thing on number 13. On number 13, you got x equals -3. Well, that's a vertical line. X equals -3. Now, all the x's are greater than. That's to the right. This is a solid line, and I forgot to tell you that the number 12 was a dashed line. Okay? Let's look at number 14. Let's go ahead and get rid of all this. On number 14, you have two equations. Y is less than. So here's -2 down here, and you have a slope of 3. So 1, 2, 3, 1. So up 3, right 1, up 3, right 1. And you just keep going on and on and on until you have this dashed line. All right? Now notice the y's are less than. So this one's going to be shading down here. So that would mean everything right here. This one has y is greater than, and we start up here at positive 3. It's a negative slope, so down 1, right 1. So notice there's this line. Now, I want all the y's that are greater than 3, so that shading is up here. Now, if you notice, I told you in the past, you only need the double shaded region. So notice this happens to be the double shaded region, and so we'll just fill that in. And number 15, the last one, number 15, 2x minus y. Now, you could solve for y easily, like they did here, all right, and then divide by -1, and that flips the sign. So you have y is less than 2x. So you start at 0, 0, because your y-intercept over here is 0. Go up 2, right 1, up 2, right 1, up 2, right 1, or down 2, left 1. It's a solid line, so that's why this is solid, okay? Now, let me go ahead and erase that. Now, the next thing you're going to do is the other line, okay? 3x plus y is less than, so again, solve for y, so minus 3x on both sides, and that's what they did, and you got -3x plus 5. So we start here at 5, we go down 3, right 1. That didn't show up. So down 3, right 1, down 3, right 1, down 3, right 1. Now, it's a dashed line. So now let's look at the shading, okay? And remember, you look at the y-intercepts for the shading. So here we go. This is y is less than, and the y-intercept was 0. So less than would be going down. So that would mean all of this right here. This next one is y is greater than 5. So greater than 5 would be going up here, so that would be this side. And I think they got the shading wrong on this one. Less than 0. Yeah, I think the double shaded region should actually be over here. So I think whoever did this answer key did the shading wrong, and I think this is the double shaded region. All right, any questions?